Hello students. So let's discuss address decoding using block decoders. So in the previous video I have shown you how the address can be decoded using a simple NAND decoder. Now if number of memory chips are there, then block decoders are used to select these memory chips. Okay, so here the block decoder which is generally used is a 3 to 8 decoder 74LS 138. You must have studied this in digital subject. Okay, so what is the pin structure of this decoder? So it will have 3 select inputs. Then 3 enable inputs. Okay, so this is G2B bar, G2A bar and G1. This is for the chip select of this decoder, for selecting this decoder chip. And you have 8 outputs. So this is Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. These are the outputs. Okay, so for this to select this chip, these 2 pins must be low because these are active low signals. Always these 2 must be 0, and the signal at this particular G1, this is active high signal, so here it must be 1. Once the chip is selected, the truth table for this decoder is like ABC inputs. Okay, and Y0, Y1, Y2, Y3, Y7. Okay, so when the combination input select input is 0 0 0, Y0 will be, there will be output at Y0. So this will be low because it is active low outputs, and all other outputs will be high. This is like when input is 0 0 0, Y0 will be selected, and when it is 0 0 1, Y1 will be selected, all others will be 1. And when it is 0 1 0, then Y2 will be selected. There will be output at Y2. Okay, because these are active low outputs, that output will be, selected output will be 0. So this is for all the combinations. For 3 it is, this is 0 and rest of them will be 1s and so on. So this is the truth table for 74LS138 3 to 8 decoder. Okay, so this decoder can be used to select a particular RAM chip if number of RAM or ROM chips are connected in the system. So this decoder can be used instead of NAND decoder, because if you are using NAND decoding, then for each memory chip you have to use one NAND decoder. Okay, so the hardware will increase. So to reduce that, we can use a block decoder like this when number of chips are present in the system. Okay, so let's see how this is possible, how this can be done with an example. Okay, so let us suppose you want to, if a problem is given like connect to 64 KB RAM chips and one 64 KB ROM chip in the system. Okay, now let's see how this can be done. Here we need to use a block decoder 7 using, or we can also specify here decoder. Okay, so here it is required, what is required? 264 KB RAM chips. Take 264 KB RAM chips. This is 1 and 2, and 164 KB ROM. Okay, 164 KB ROM chip. So these three chips are to be connected. So here we can use a decoder. There are three inputs, select inputs. Okay, enable inputs you specify here, and there are 8 outputs. Okay, this is the decoder chip. Okay, so here 64 KB means how many address lines are required for 64? 2 to the power of 16 is 64K, isn't it? 2 to the power of 16 is equal to 64K. So 16 address lines are required, A0 to A15. Okay, so you can connect A0 to A15 here. Here also you require, because this is also 64K, A0 to A15. This is also, so processors address lines, see here like exactly in 8086 processor, the memory interfacing will be different. Here for easy understanding purpose, first I am taking because you know 8086 is a word processor. It can process 16 bits of data at a time. Okay, but these are all byte chips. This is byte organized memory. Okay, so you can consider like this particular designing, it can apply for 8088 processor, which is a byte processor. It has 20-bit address lines, but data lines are only D0 to D7. Byte, 1 byte of memory only, 1 byte of data only it can process at a time. Okay, so this you can consider for 8088 processor, or in case of any byte organizer like 8085 processor where only data bus is D0 to D7, or a microcontroller where only D0 to D7 8-bit data bus is there. But in case of 8085, address bus will be only 16. Okay, so the maximum capacity of memory it can access is only 64 KB. But the method is same, like instead of 64 KB you can have, if it is a 8085 system, it may be asked for you to just interface 8 KB, so many number of 8 KB chips, or uh, uh, 1 KB chips. Okay, that in that way the problems can be asked. So here this one you can consider, this is for 8088 processor. Okay, uh, my main purpose is for you to understand the decoding, address decoding. In the next video we'll see how exactly the memory is interfaced with 8086 processor, because it is a word processor there is a change in how the memory is interfaced with the processor. So that we'll see in the next video. Okay, so here now let's see how the address decoding can be done if multiple chips are there, memory chips are there which are to be interfaced. So A0 to A15 are used here for the memory location because the capacity is 64 KB, 16 address lines are used here. We are remaining with how many lines? A16 to A19. Okay, so here we can use A16, then A17 and A18 we can use as select inputs of this 74LS this decoder. Okay, then we are left with one more input, that is one more address line, that is A19. So we can use that A19 with G1, that is the enable input. Okay, for this chip to be selected, A19 must be always equal to 1, and here because these two must be 0 for the chip to be selected, we can ground these two, so always they are low. So when this chip will be selected, when G1 is high, that is A19 address line is high, 1. Okay, then depending on A16, A17 and A18, one of the outputs will be low, one of the outputs will be selected. So each one of them we can use for the chip select of these memory chips. Okay, so the chip select of this RAM, so we can use Y0 to select this particular chip. Okay, and let me use Y2 to select this particular chip. So when Y0 is low, this chip will be selected. If Y2 is low, that means Y2 when it will be low? When this is 0, 1, 0. Y0 when it will be low? When A16 to A18, these three are 0, 0, 0. Okay, so the address range will change because the combination here it is changing. Okay, then for ROM I can use Y7. Usually ROM will be at the end, like high address are used for ROM because whenever the system is reset, first location the processor will access is FFFF0. Okay, which where there must be a BIOS programs, basic IO system initialization programs will be present. Always the system initialization programs must be present in ROM. So the end addresses we use for ROM, and the rest of the memory space we can use it for RAM. So I'll take Y7 to enable this ROM. Now let's see. Here I need not show, like all A0 to A15 are connected here, and the data bus will be there here, D0 to D7. So that all the processor data bus will be connected here. Okay, and one more, like in case of RAM, write bar, read bar. So processor's memory write bar is connected here and memory read bar is connected here, in the same way with the other chips. But in case of ROM, only write bar. Read bar pin will not be present in case of ROM because you cannot, only read bar. We cannot write to a ROM. Okay, once it is programmed and kept, you cannot write, you can only read from the ROM memory chip. Okay, so this is how we connect. So it became so simple. Like if this decoder is not used, we must have used one NAND decoding for this one, another NAND decoder for this one, and separately we need to use NAND decoders for each one of these RAM chips, memory chips. Okay, now we'll see what is the address range. already we have seen in the last video how we can write the address range. So A0 to A19, these are the address lines. So here for our designing, the way in which we have connected the memory chips here, for this A19 must be always 1, then only this decoder will be enabled. Okay, then for now we'll see what is the address range for each one of these memory chips. So why not is used to select RAM 1. Okay, it is used to select RAM 1 memory chip. So here why not must be enabled to select this particular chip. So for this to be enabled, the a combination at A16, 17 and 18 must be all zeros. Okay, the combination at A18, 17 and 16, it must be 0. And till A15, this is A0 to A15, these are used to select a particular location in that particular chip. Okay, so what will be the start combination for all these pins? This will be zeros. And what will be the end combination for these bits? 1, 1, 1. Okay, so for RAM 1 chip, what is the start address in hexadecimal if you write? It is 8000H. And the end address is 8FFF. Isn't it? Now let's see what is the address range of our RAM 2 chip. RAM 2 chip is connected to Y2. Okay, so what will be the combination for Y2? For Y2, it is 0, 1, 0. For Y2, it is 0, 1, 0. I can connect Y1 also to select this particular chip. Okay, so accordingly the address will change here. Okay, 0, 1, 0. And what is the start address combination? All zeros to all ones. Okay, so what is the start address of this RAM 1 chip here? This is RAM 2. For RAM 2 chip, what is the start address? This is 1010. Okay, that means A 0000H, and the end address is AFFFH. So this is the address range of RAM 2 chip. So what will be the address range for ROM chip here? A19 must be 1. ROM is connected to Y7. Y7 means what is the combination here? It will be all bits equal to 1. So what is the range? All bits 0 will be the start address, all bits 1 will be the end address. So what is the address range for ROM here? F 0000H, and the end address is FF. So as we wanted the end addresses starting from this FFF to F0, this is in the ROM where the system programs are stored, so that the processor, when it is reset, the location which it accesses will be in ROM. Okay, so this is the mapping for address range for ROM. So this is how when multiple memory chips are there, number of memory chips are there which are to be connected to the system, in the system, to the processor, then this is how the block decoder can be used, so that easily it can be designed. Okay, in the next video we'll see how exactly, as I said, in 8086 processor, the memory interfacing designing will be little bit different because it is a word processor. Okay, so we'll see that in the next video.